Okay, so welcome to the 8th and hopefully last video for section 8.4, so definition. So a lemniscate, that's what we're defining. A lemniscate is a polar graph of the form number 1, r squared is equal to a squared sine of 2 theta, where first along theta equals to pi over 4. You'll notice that's pi over 2n as before. And number 2, r squared is equal to a squared cosine of 2 theta, where again the first, because it's cosine, will be along theta equals to 0 radians, where a is the petal length and the number of petals n is always 2, because we have r squared here, not r, so it's different. Okay, so for example, plot the following lemniscates. And you'll recognize the lemniscate as an infinity symbol. So if we have r squared is 9 times cosine of 2 theta, we have that a squared is 9, which means that a is 3. And we already know that there's only 2 petals, so let me show you what it looks like. So because this is cosine, we know that first petal will be along theta equals to 0, and it has a length of 3. Okay, so we've got, and since there's only 2 petals, 1, 2, 3, 1, 2, 3, they're always in the opposite direction from one another, because I divide 360 degrees by 2, and we get an infinity shape, or a lemniscate, or a bow tie. There you go. That's the cosine lemniscate. It's always oriented along the x-axis, of course, because it's cosine. And now let's do a sine lemniscate. So let's say we have r squared is equal to 25 sine of 2 theta. Okay, so in this case, the a squared is 25, which means that a is 5. And we know that the first petal will be along theta equals to pi over 4. Or we could have done pi over 2n, where my n, the coefficient of theta, so n is 2. So that means theta is pi over 2 times 2. So that's where we get the pi over 4 from. Okay, so pi over 4. And the spacing, let me just reiterate the spacing here is 2 pi divided by 2, which is just pi, so 180 degrees apart. Okay, so now we need to draw 5 concentric circles. Let's see if I can do this one, hopefully. So let's see if I can paste the other. Yes, I can paste the circle, good. So here's my first circle, my second circle, my third, okay, come on. My third circle. Oh, is it going to be... Why does it do that? I wonder. Nope, okay. It's going to defile me. Okay, so then fourth. Yep, of course it's going to... Okay, so let me leave myself some room. Going to move this down a bit. And maybe to the left, so down. Okay, let's make these axes a bit longer. And let's put another circle at 5. Nope, okay, come on. You can do it. You can do it. I know you can. Don't. Okay. Holy free holy, we did it. Okay. So all I need now, because lemniscets are either along 0 or 45, all I need is a 45-degree reference angles. Okay, so my lemniscet goes through the pole. This one has a radius of 5, and they're 180 degrees apart, the petals, that is. So my infinity symbol looks something like so. Oh, almost. Let's see. Something like that. Okay, so not drawn very well. Actually, I really don't like that. Let me try this again. I guess that's good enough for government work. Okay, so these are lemniscets. Okay, so let's consider something. So let's consider r is equal to a times cosine of 2 theta. So in this case, we know that the number of petals, n, is going to be 2 times little n, which is 2 times 2, which is 4. Okay, so let's consider r is equal to a times cosine of 4 theta. So that means that the number of petals, n, is going to be 2 times little n, which is 2 times 4, which is 8. Okay, now let's consider r is equal to a times cosine of 6 theta. So once again, the number of petals here will be 2 times little n. So in this case, that's going to be 2 times 6, which is 12. And for good measure, let's do a couple more. So I'm trying to look at all the even coefficients of theta. So the next even number is 8, which means the number of petals, n, will be 2 times little n, the coefficient. That is 2 times 8, which is 16. And since I don't like even numbers, even though this is all about even numbers here, let's go for 5. So let's have r is equals to cosine of 10 theta. So this means that n, the number of petals, will be 2 times little n, the coefficient of theta. So this is going to be 2 times 10, or 20 petals. Okay, so that should be sufficient. And what I'm going to do is I'm going to highlight the number of petals here. Let's call these all, what color should I use? Hot pink. There we go. Okay, because each of these is a multiple of 4. So this is 4 times 1. The next one, oops, is going to be 4 times 2. The next one is going to be 4 times 3. The next one is going to be 4 times 4. So the number of petals is always a multiple of 4, right? So I can never have a rose with, let me asterisk that. So a rose has only an even number of petals. Number of petals that is divisible by 4. Divisible by 4. So that is, i.e., so if I have r is equals to a cosine of n theta, or r is equals to a sine of n theta, n is even if and only if 4 divides or goes into n. Okay, so I cannot have a rose, cannot have a rose with 2, 6, let's see, 10, etc. petals. Only multiples of 4. These are just multiples of 2, not 4. So note, a limousin a lemniscate, not limousin, a lemniscate has 2 petals, but note that its r squared equals to a squared cosine 2 theta. And it's because of the r squared here. So that this is not a rose because of that squared. Okay, so I just wanted to bring that up, and this is finally the end of section 8.4.